Static MAC Authentication Bypass, or MAB, uses a MAC address for both the username and the password. This is the most basic form of authentication, used for devices that simply do not support 802.1x. But there are some concerns. Because MAC addresses are easily spoofed, they are a relatively weak form of authentication. Even so, they are still a good first step for device identification. So, on the plus side, MAB enhances your visibility into the network. The system can link the device IP and MAC addresses with connected switch and port. Quite useful for security audits, forensics, and troubleshooting. You get identity-based services. All of the 802.1x dynamic authorization techniques also work with MAB, VLAN assignment, ACLs, and SGA. Also, MAB acts at layer 2, allowing you to control network access at the edge. MAB can be deployed as a fallback mechanism for 802.1x. When endpoints connect, the NAT tries to use 802.1x. If there's no response, it tries MAB next. Of course, MAB can also be deployed as a standalone authentication mechanism. And remember the primary use case for MAB. It can authenticate non-802.11 capable devices. Now this is good stuff, but there are limitations. Remember, network access devices learn the MAC address of endpoints and send this to the radius server as both the username and the password. How does the radius server know whether these MAC addresses are valid? Well, this requires a pre-existing database of acceptable MAC addresses, which you have to create and you have to maintain. Could be a little bit of work. And when used as an 802.1x fallback mechanism, there's delay. MAB waits for IEEE 802.1x to time out before validating the MAC address. These delays can negatively affect endpoint functionality, although mitigation techniques are available. Now remember, MAB only authenticates devices, not users. So different users logged into the same device will have the same network access. And finally, unlike 802.1x, MAB is a fairly weak authentication method and can be defeated by spoofing a valid device's MAC address. Okay, so we understand the benefits and concerns. Let's take a look at how MAB operates. MAB enables port-based access control based on the learned endpoint MAC address. It provides a method to handle 802.1x exceptions. Certain MAC addresses are allowed to skip the regular 802.1x authentication process. Now initially, endpoint identity is unknown. When the switch receives that first frame from the endpoint, it learns the source MAC address. Now it doesn't forward this frame nor any subsequent frames because the port is not yet authorized. However, it forwards this MAC address to Cisco ICE as a radius access request message. Assuming that this is a valid MAC address, Cisco ICE sends an access accept message and the port is authorized. The switch uses source MAC address filtering to help ensure that only the MAB authenticated endpoint is allowed to send traffic on this port. Okay, let's look at a scenario where MAB acts as a fallback mechanism to 802.1x. In the initiation phase, the switch detects port link up and initiates authentication by sending an EAP request identity message. If the switch does not receive a response, it retransmits the request. Eventually, 802.1x times out and the switch proceeds on to MAB. In the MAC address learning phase, the switch allows the port to accept a single frame and thus learns the endpoint MAC address. Now, this and all prior frames are discarded. The switch sends a radius access request packet, which includes the endpoint MAC address, as 3 separate attribute value pairs, or AVPs. It is used as the username, the password, and the calling station ID. In the authorization phase, the radius server validates the MAC address. If valid, it sends an access accept message. This message informs the switch to allow endpoint port access. The message might also include a dynamic VLAN or DACL. If the MAC address is invalid, an access reject message is sent, and all endpoint frames continue to be dropped. However, if alternative authentication methods are configured, the switch may attempt 802.1x or web authentication or deploy the guest VLAN. In the accounting phase, if the switch successfully applies the authorization policy, it can send a Radius accounting request message to the Radius server with details about the authorized session.